Hi everyone, welcome back to day 5 of Advent of Code. Today's question seems a little tricky. Let's see what it's like. So what we have to do here today is that there's one elf that needs our help in fixing a silly launch safety manual in which there are a bunch of rules based on which the manual is supposed to be printed, and there are also a bunch of pages. So there are two things. One is the page ordering rule and also the pages to be produced in each update. So these are the two things, and that this is what the input looks like, in which this first part is the rule, which is saying that if 47 and 53 exist in the same update, then 47 should come before 53. And for that, these are the updates in the bottom. So here we have 75, 47, 61, 53, 29. So we can see 47 exists in this, and also 53 also exists in this. So 47 should be before 53, and it's not necessary that it should be immediately before or anything like that. So we just have to find out how many of these updates as per part 1 is following this rule, and if it is following the rule, we have to sum the middle pages in whatever is coming out. So cool, let's try and code this. Let's copy the input that they're giving us first. All right, after a lot of mistakes, I finally finished writing the code for this. Now let me explain. So what we're doing is, first we're processing the input. The input is in such a way that we have uh, this part, which is the rules part, and the updates part. So it is separated by two returns. So we're going to split it according to that, and we'll get two parts: the rules and the updates. So here we get rules and updates by splitting it with the double return, and then we split these rules again, which are this part of it, by the returns character, and then we will split that again into two parts using this and convert these to a number. That's what we're doing for the rules, and for this we're just going to separate it using these commas and convert it into a number. So that's how it is. We are separating each line and then splitting it with the comma and then converting it into a number. Then we are returning it. That's what process input does. Then make rules map. This is just making a hash map of all the rules. So let me log that so that it's visible. It's like this. Our rules for 29 should come before 13, 47 should come before so many of these. According to this, it'll just make it a smaller map of all the items. So that was what the rules map does. Then find valid updates. I am not directly summing it in case we need this information for the next part. Also, it's easier to debug if we mess up using this. So in this, we are going through each update. We have this. We are going to check if it is valid or not. So we're maintaining the state here. We're going to take the key, which is basically this. I mean, we'll take the ith element of the update, and then we will use that as a key while referring to this map. That's why I've named it key, and we'll get all the values it should be before. So I could name this as all pages. And if the pages are null or the length is 0, which is possible, like there is 13 here, which does not have any rule that it should be before this. So that if there is no rule, we'll just continue with the next page because we can skip those. But if it has a rule, for every rule that is there, we will check if the index is either not existing in this update, as in if we have this update here, let's take this. So if 13 is not here, then it's good, we can continue, it will be valid. Or if suppose instead of 13 we're looking for 61, if 61 is here and we are looking for 75, like with the key 75, it should be the index of 61 should be greater than the index of 75. So that is this part. It should be, if it's in valid, then it should be greater than the index of 75, which is the ith element right now. Okay, so this was done. I mean, I can think of a few edge cases, so I'll just make a note in case our thing fails. What if there are multiple of the same number? I just thought of that, so I'll make a note of it. Okay, so we are getting 143, which was what was expected as per our sample input. Now let's try it for the actual. Let's hope for the best and go for it. Awesome. So we didn't have to consider the edge case for part 1, which is not a good thing, but it's okay, at least we thought of it, right? Okay, now let's look at part 2. Okay, so in the next part, what we have to do is we just have to correct whatever the incorrect updates were. So although we kept a track of the correct updates, we didn't keep a track of the incorrect ones. Now we'll just have to do that. And then we have this kind of a rule. So I mean, this was failing the rule before because 47 was before 61, and I guess here 61 was supposed to be, let's just check, it is not in the correct order. It would be print 75 before 97. Are they using that? Okay, they have corrected it. So what 75 and 97 are here. 97 was supposed to be before 75, so they have corrected it, and then they are going to take a sum. Because they highlighted it, I got confused. Okay, so we have to correct it. I have an idea, but let's see if that'll work. Okay, so what we are doing here is we have everything else is the same, but uh, here in the find valid updates method, I think I'm very sleepy now. So excuse me if I make mistakes while talking or if I slow down. But anyway, this invalid updates is something we've added. Whenever it's not valid, we will push the update to this invalid updates and we will return that as well. We don't really need a valid updates anymore, but I just left it. Uh, I think there's no value for space in this world anymore, so we don't care about the space consumption, memory consumption, I mean. So anyway, invalid updates, I send it, and now I fix the invalid updates. In this method, we're just iterating over every update, and what we are keeping track of the index of the key, which is the first whatever element we are currently looking at, and we keep a track of the index of the value as well. If the index of the value is less than the index of the key, we just recreate the array in such a way that it is inserted in that place. So I've taken this as an example. So if it's 1 2 4 5 3 6, and we are going to assume we have to sort it in ascending order, which means 1 should be before 2 3 4 5 6, 2 should be before 3 4 5 6, 4 3 should be before 4 5 6, and so on. So what will happen is when it comes to 4, 4 will be okay because it's checking 5 6. When it comes to 3, it will see that 4 is behind and 5 is behind, but it will first see that 4 is behind. So what it will do is it will um, slice the array from here to here, which is till the index of the value, and then it will put it in one place, and then it will put the key, and then it will take the remaining part before the key and then the part after the key and then make it one array. This is what that is doing, and we will make the main update itself as this, because then when it's basically like bubble sort sort of, but instead of sorting it we are using some reference, and then we will refresh what the current index of the key is, and we will go on like that. One way I can think of to verify if we are getting the right results is to reuse this. How we can do that is let a b is equal to fix invalid updates, sorry, find valid updates, and send the rules map with the new valid update. So what this will give us is valid ones and invalid ones. Ideally the length of A should be the same as what the initial length was, and the length of B should be 0. Okay, we're getting 0, so 123 is what was expected. So now we can check with this is a better style, right? Anyway, one line of code we have to comment and uncomment, comment again and again. So let's look at it. 5833. Let me quickly put it here. Oh cool guys. Oh shoot, I forgot to share the screen again. Alright, so we've got this, we've got the second star. Easy question. I think I made a lot of mistakes in the second part. I was super sleepy. Anyway, I hope this makes sense. If there is an efficient way and you guys know about it, leave that in the comments. If not, I will take a look anyway and put it as another video if I find anything. For day 4, I couldn't find anything more efficient than what we had already done. There may be ways, but I couldn't see any. Yeah, anyway, until tomorrow. See ya, bye.